Welcome back, everybody, to the Coach Rob Podcast Network, Navigating Amateur Motocross, episode number 24, brought to you by our good friends at Precision Transport. The man, the myth, and the legend himself, Mr. Derek Harris. How you doing, brother?
I'm good, man. Good to see you. I guess how you been? It's been a little bit of a while.
Yeah, well, we can't talk about where you've been because you'd have to kill me if I talked about it. But congratulations, getting some calls from some pretty high-profile teams, doing some testing all over the country, and it's all right. We have to change our schedules around a little bit, but I want to. You and I haven't had a chance to talk about these numbers, but our download numbers are like quadrupled in the last
Oh, wow.
last 3 months. So the numbers of downloads, a lot more people are listening to it in audio, which is cool. Some people like to watch it on YouTube. A lot of guys that have it some background conversation, and then the downloads on people listening to it just on like Spotify and things like that. So I want to
Nice.
thank all of the people that have been with us since day one, and all the new ones. We always welcome. We promise we'll bring you a new subject every month, and it'll constantly grow. So if you're dropping into this podcast series and you're like, man, they're talking about some stuff that's very sophisticated, go back. This will be our 24th conversation together about navigating amateur motocross. So 23 previous shows on a lot of different subjects. But we're always in a catch-22, Derek, because we don't want to put the people who've been with us since day one asleep with redundant information, and we don't want to overwhelm the new listeners. So if you're hearing things that are a little bit repetitive, that's the reason why. And if you're hearing it for the first time, don't be overwhelmed with it. That's for sure. I'm proud to have Derek on this show. Smartest man I've ever met when it comes to building motors, and your ability to convey it is always very refreshing. I get a lot of DMs and messages. So thank you, brother. Today, I wanted to talk a little bit about strength training. Um, when most people think of strength training, they think about a buff dude, and we'll talk a little bit about that. There's some strength training that's very unique to racing two wheels, which we'll talk about. But I want to open today's conversation and challenge you a little bit. When I think of a motor being strong, it's easy to think, oh man, I just buy a brand new bike and I'll always have a fresh one. Not everybody can do that. I know I certainly can't afford to do that. What are your recommendations? Let's say I pick up a bike, it's got 25 hours on it. Is it always just going to be about rebuilding the top end? When do you do the bottom end? And I know for a lot of people that may sound familiar, but where do you start as an engineer?
Well, this is a great question, and it's coupled with experience, so just knowledge on a platform, as well as a couple other factors. But on a two-stroke, top ends are probably your best friend to keep your new bike running as good as it possibly can, amongst a couple other things, like you really want to make sure your reeds are not chipped or worn out. Same thing with like making sure your carbs functioning correctly, just cleaned and no leaks and all stuff like that. So there's a few things there, right? But the top end on a two-stroke is your best friend. You want to keep that bike top shape. You have to keep fresh piston in it. And just to elaborate as to why that is, and maybe we give me an analogy after this as to how this would relate to like strength training of the body, is that piston goes up and down a lot of times per second. And it's kind of hard to describe this, but if you just shake your fist forward and back, and then if I put a weight in there, like a shake weight or whatever, it gets hard to do, right?
Mhm.
And the reason it gets hard to do is we have what is called the inertia aspects. And so we have to accelerate that weight to slow it down and then speed it back up and back and forth. Well, your piston is doing that. It goes up and down. It actually stresses the piston, like it's forcing a load through it. And these forces are so high, it's hard to really put into words what those numbers would be like. But if somebody were to punch you with how hard your piston is moving with that size of a piston, it would absolutely rock your world. It could kill you, right? It literally could kill you. So it's a tremendous number of force that's going on those parts. It's stressing. So yes, there's engineering and design that allows them to live, but at the same time, they are slowly but surely getting stressed to the point where eventually they can break, number one. But more importantly, from a performance standpoint, which is what an amateur national racer cares about and a local racer cares about, is that it's wearing out the ring land and it's wearing out where the ring seals. And then that's going to give you less pressure that seals well. And then additionally, you're getting a little more wear on like the skirts so that it's going to have a little more play. And anytime it has just a little bit too much play, we do want play, but it has too much, when it rocks, those rings can't seal as well. So we just don't capture all of the power that all the air and fuel we put in there is really hard. That's an engine developer's job. We want to make sure we extract everything out of it So unfortunately, as that ring seal goes away, that performance level goes away. And then the same thing applies to the ring. And here's a good analogy about two things here, which is the ring is on a two-stroke crossing over your ports every single time. And if you really look in your two-stroke cylinder, there's a whole bunch of windows in there, a whole bunch of holes. And those holes are how air and fuel get into the engine. We have to have them. Well, every time that ring goes across this big gap, it basically wears out a little bit. There's just no way around it. And that's another negative of a two-stroke design. The ring can't spin around and wear evenly all the way across the ring, which is what a four-stroke does. And there's no holes in a four-stroke cylinder. On the two-stroke, it's rubbing, it's just like you rubbing one spot over and over and over and over, and eventually it wears out. So if you take a 10-hour two-stroke ring, put it in your bore, square it up with a piston, put it down there and put a light around it, you will see light all the way around that ring in various spots. Almost always you'll see it where it's crossing these port areas, these contact areas. And so that's not going to seal well, right? And so as it leaks a little combustion pressure, it's not as good. And then also we use the piston in a two-stroke to suck the charge in underneath the piston. And so it's not going to do as good of a job of that as well. So that's your best friend. Service your top ends. The more often, the better. I mean, realistically, if it was, at the former national race days, back when they raced two strokes, it was not uncommon for teams to do top ends between motos. So they're talking 35 minutes. At that level, at that price point back then, probably it cost was a $50 piston back in that era, if not less. Nowadays, call it a $100 to $150 piston, is nothing for a race team when you've driven the rig out there and you paid the mechanic and you paid the hotels and all that stuff. Well, $50 to make sure my bike runs good and get to inspect it, make sure that everything's good, we don't have any issues, that kind of a deal. So long story short, number one. 2, keep your reeds fresh. 3, the number one thing for performance that people miss is being jetted on the money every day. That's a little bit harder, but obviously keeping up with your parts mechanically is great. I'll let you jump in, and if you have any questions on that, and then we'll elaborate onto the crank after
Yeah.
that.
I've got a big question for you, and I'm not an engineer, so if this sounds really naive, I apologize. Why don't we come up with better materials that wouldn't allow those porting holes to get worn out? I'm sure it's gotten better over the years, but isn't there a material that has almost, I'm never going to say won't wear out at all? Why haven't we changed the materials of the cylinder?
That's a great question. I think that we've kind of reached close to our peak. Currently, the cylinders run a Nicosil plating or some variant of that, and that is a very thin, very hard, diamond-like hardness surface for the ring and the piston to ride on. And back in the day, they had cast iron liners. Sometimes they had steel liners, like the old sleeves or whatever. And those weren't bad, but they were a little soft. And so the liner itself would wear out because the ring's rubbing on it. And then, of course, you would have to go to the next size piston. Back in the day, there would be 3, 4 size pistons you could go to. And that was just because over time, your liner actually wore out. Nowadays, the Nicosil itself, as long as you went through normal, correct operation, no sand ingestion through your air filter, and proper premix and proper premix ratios and things like this, you pretty much won't wear out that Nicosil for a race bike for the life of that race bike. I mean, we're not talking like these two strokes could never, ever, ever in a race, in a motocross, ever survive in the car world. They just can't go that many hours. And we'll get into that in a minute. But that's a great question. So I think we're at the moment, that's just the best material on the planet we know of on how to put it into a cylinder, something that can be machined and honed. Has to be honable and machinable to make it round and straight. And then, of course, create a crosshatch pattern, all the things that are required to make it work. They've worked hard on that on the OEM side for years and years and years. And that's kind of what, we've come up with. On the ring side of things, they do run steel rings now. They used to run cast iron and ductile rings and stuff like that. So the ring itself is the strongest it's ever been. There have been a bunch of companies that have played around with coatings on the rings to try and improve this durability. So like a titanium nitride is something that I've heard has been used. And there's a few other things that I've heard have been tried. So they've done a lot. You know what I mean? They've really tried. But unfortunately, anytime you've got a hole and you got to go across it, we have lubrication concerns there. Like we interrupt basically lubrication. And so we're more prone to just rub metal on metal. And anytime you rub metal on metal, wearing out parts. There's just no way around it. And then I think the other aspect of that is like I said, anytime you rub one spot, we can have so on a two-stroke, we kind of like on a race bike, we are putting as much hole in there as we can. I mean, literally, that is what your porting arrangement is. it is all holes. And then we have little itty bitty dividers between those ports. So if you look in your cylinder and you've got a KTM or something or YZ, if you really look, I mean, that ring, when it's going across all of those holes, kind of at the intake and exhaust, it's supported by basically a grand total of maybe 7 millimeters of contact. The ring is, for the most part, just floating in space around those ports because we need those holes to get air into the engine. If we give it more support, we have less hole, right? We have less airflow. And so that also is an issue because we don't have a lot of contact area for that ring to be distributing those loads across. And that's a two-stroke. Now, four strokes, this is why four strokes, if you have a solid bike, you're not hard on your equipment, we'll get that. But four-stroke rings themselves will last infinitely more hours. Like, as an example, not in the racing world, but if you own a KTM 500 and you're a dual sport adventure rider, there's guys going 500 to 1,000 hours on top ends. That's obviously unheard of in racing, but the rings are capable of lasting that duration. Sure, they slowly wear out, but they seal plenty fine. They go fine, all of that. So your question about materials is great. I actually think like F1 is an area that pushes these concepts. And so with modern 3D additive manufacturing, you can print parts now. I don't know for sure. I'm not in that world, but I mean, people like myself are always looking at it. I've been told that like modern F1 race engines right now, because of the turbocharging and things, I've heard some of them are running steel pistons. And then of course they're having some crazy metal matrix materials. And because they can 3D print them, they can actually make a part. The reason we use aluminum is it's light, but it's not as durable as steel. It's not as strong as steel. And so it has some negatives. If you could just have a really specialty designed part that was like, say, hollow or gridded inside, that, areas that we didn't need the strength, you could get a steel part to weigh almost the same or the same as aluminum with a higher durability. So that's kind of some things I have heard are occurring in that space. And as that additive manufacturing becomes more prominent, I think you will see maybe some material advancements occur. And it's funny, it's going back to like a quote unquote non-aerospace material, right? Steel's real basic, but steel's a great material. It's just too heavy for a piston. So that might come about.
Difference? What's the RPM difference between a Formula One car and a two-stroke?
Well, it's changing, and I don't keep up with F1 as much as I used to on the current regulations, but they used to be like a 18 to 19,000 RPM engine. And so they were amazing. Dirt bikes, I mean, your two-stroke, believe it or not, when you hold them wide open in the air on a 125, 65, 85, whatever, and you hear that thing, sometimes they're jetted right, and they just get lucky and they zip up, everybody's like, dang, you hear that bike? And a lot of the bikes do it. If stock bike will do it occasionally. I mean, you're turning 16, 17,000 RPM.
Okay, so it is comparable though.
Yes. Well, under peak power, where your power is placed, like down a straightaway where you should be, they're around 12,000. Every single two-stroke from 65 to 125 is 12. The new F1 cars are right around that. I think they've lowered the RPMs over the last few years because they went turbocharged. They wanted to make it more about the powertrain and hybrid systems and less about valve train. So they've backed off. But so now they're very comparable, right? So that's a great question. People are trying, but it's tough. Also, it's tough from a cost standpoint. Right now, it probably costs them in reality $10 to manufacture your piston. And then, of course, there's a ring cost, the wrist pin cost, clips, packaging, shipping, import fees, tariffs. So by the time a wholesaler gets it, it's at $70. And then by the time a dealer gets it, it's at $100. And then by retail points, $150, right?
Mm-hmm.
If you decided to additive manufacture it, 3D print it, you need a way more, less efficient machine on manufacturing. It takes way longer. And it's a lot more design time, all these factors. Maybe you'd end up having to go buy a $500 piston. I mean, I don't know, maybe the motocross community would, but that's one of those areas where even if the piston itself was super durable, we still have the restriction of the ring, which until somebody comes up with something even better, right? Well, we just haven't figured it out. So
have you noticed a weakness in the material?
Like aluminum or steel, or
when we look at that piston, because I always get, and again, I'm not an engineer, but I hear about, so-and-so company is cutting costs. They're going, they're outsourcing to cheaper materials. And I'm thinking, gosh, the last thing I want to do is put a cheaper material that's going, especially when you're dealing with high heat, high RPMs, everything that you've elaborated on. I look at strength in the body and I go, okay, yeah, we need to lift more weight. So if we hit the ground, we bounce and we don't break. When I think about the strength in the realm of power, it's like, all right, I want a piston that, yeah, it's going to heat and expand, but you hear about some of these pistons coming out of the manufacturing plant that are like butter. And then you're a motor builder that's got cheap OEM parts that people don't want. They think you're just trying to spend their money, but you're like, that's why I'm fascinated with this conversation. When, okay, I understand there's ports and stuff, and I understand the rubbing, and that's the highest point of friction, and it's going to wear out. And I'm thinking, well, on one hand, you've put an oversized radiator on, but then you've got this butter of a piston. Then you get a really good piston, but then you got a butter of a ring. It's like you're chasing this constant combination. Like I can say, are you fast because you're strong? You have good endurance, or you have a high lactate tolerance? That's all physiological. When I talk about the strength and the power of a motor, I'm fascinated with what you're saying because, okay, we've talked about the material of the piston. We'll get to the rod and stuff like you were talking about. Then you look at the idea that, okay, you've got a high RPM and a high heat. How are you dealing, or is there even an issue? I've heard so many people like, man, these OEM parts are just turned into garbage.
Yeah, that's a great question. It's a tough one. So let's take aluminum that we use for pistons as an example. Every material on the planet just has inherent qualities, and then material engineers have over the years worked their butts off to try to optimize these materials, right? Okay, how do I make an aluminum that has a really, really high strength? Because basic raw aluminum is very weak. It's incredibly weak. And same with really truly basic raw mild steel. Like it's not weak, it's way stronger than aluminum, but it's not what's up there in the materials world, right? So there's certain steels out there that are incredibly strong, three times, four times, seven times stronger than like a base mild steel. And the same applies to aluminum, like an untreated basic raw aluminum versus a 775 T6. The actual strength is less than half.
Mm.
So they mix in, but they mix in these other elements and whatever. And I'm not a material science engineer. I know a little bit about it because we research for parts that we want and we do our research. And my dad's an engineer, so I rely on him, but he's not a materials science engineer. Obviously, we just know the qualities of those materials. We're not the ones engineering them. My cousin's actually a material science engineer, which is ironic, but he lives in Austria of all interesting places. So long and short, let's take two examples for pistons. What are your options? Right now in the market, you can buy some version of a cast piston. So typically that's going to be a Vertex, an OEM on a two-stroke, or a Pro X. Okay, so that's on the two-stroke realm. You can buy OEM, you can buy a Vertex, or you can buy a Pro X, and all three of those are going to be a cast aluminum. They pour it into a mold. When you cast aluminum, there are some positives. And some of those positives are that you can design the shape of the piston a little bit differently than what we can do with a forging / machined piston. So when you cast it, there's certain shapes you can do that you just like for example, a cylinder head, right? If I have a cylinder head, it has water cavities through the head, or a 4-stroke or a 2-stroke, whatever. You cannot do that one piece through machining. It's not possible to get those hollows and cavities, right? So we can do things in castings that we cannot do through machining and forging. On the flip side, we also have different materials. There's different levels of aluminum in casting that work well that way when they're melted and how they work and you put them together. So typically, a cast piston that we are going to run in a dirt bike will have a little bit higher silicon content. And that silicon content gives it really nice abrasive resistance and hardness. And so it's actually really good at rubbing. That's a really nice quality of it. It's going to have great rubbing durability. However, it's more brittle and it's going to have less what we call ultimate strength, like its ultimate strength level. And it's also going to have less of what we call high cycle fatigue strength. And when it decides to fail, it usually fails catastrophically. So if you run a cast piston too long, when it decides to break, it's like it exploded. The thing just, lets go. And that has to do with a lot more things that are over my head, but the grain structure of how it's poured and how the line, how the molecules align and all these things, plus its base material. What we do in forgings, so the other piston you can buy, it would be a Weisco, a Wassner, and this is the two-stroke world. And I might be missing one. I think Vertex makes a few forged pistons, so they do actually make a couple. What they typically do, and they're going to pick a material such as a 4000 series material that's kind of popular, or they're going to pick a 2000 series aluminum, and they each have their inherent qualities. Like 2000 series aluminums are very tough because they're ductile and they have a good strength number, but they're not very hard. And so they're like something you can hit with a hammer that won't shatter. You hit a cast piston with a hammer and it shatters, but you can hit one of these with a hammer and it won't shatter. It might dent a little bit, whatever, but it won't shatter on you. However, it's not as hard. Because it's not as hard, it's more prone to rubbing away over time. So like your ringland and the skirt wear is going to be worse. And then also they have different thermal conductivities. So like a cast piston expands less because it's got more silicon in it. And so it just doesn't grow as much with heat. Whereas a forged piston, typically they have really good heat transfer properties. They have some materials in there that transfer heat better, like some coppers and stuff. And when they get hot, they grow more. Well, this becomes, as an engine, guy, this is a problem depending on what you're doing, because if your bore size and your piston design are the same between the two, you would seize your forged pistons
That
because they're
makes
just going to
sense.
grow too much, right? So you have to have that all accounted for. Now, granted, the piston manufacturers know all this stuff. They know it forever and they work on it. But that said, there's some design, positives and negatives and whatnot. So if you decide to run a forged piston, the positives are it's pretty much indestructible when it comes to like a catastrophic failure. It's going to wear out more quickly, though. The ringland surface and the rubbing surfaces will degrade more quickly. However, you could run it a lot more hours without it never shattering on you, right? Whereas like
Okay.
a cast piston, this is why you change them out. A cast piston will show almost no signs of real wear. You're like, man, that thing looks great. I got a little skirt rubbing and the coating wore off, but I measure it out and it's right in spec. We haven't even lost a thou of clearance, right? But all of a sudden, one day you're out there and boom, and your bike just catastrophically fails. This is what's happening on the EFI KTM 125s, like clockwork. These people are running these parts kind of like they used to. For whatever reason, I have some ideas on it, but won't get into it. That bike is eating up cast stock pistons at a way faster rate than the old bike. So guys who put like national racers who want to push this bike, say past 15 hours, it's a disaster. And so the
So
manual
15,
says,
about
yeah,
15 is about the threshold.
on
Okay.
that bike, if you don't do that and your kid's fast, you will be, we've seen it time and time again. And it's funny because I had a shop out of Kansas, Bees Moto, working with one of their guys, and we'd done a package for him, and he grenaded one. And I looked at it and said, hey, man, I really think that that's high cycle fatigue. You can look that up online. It just means that a part gets stressed a whole lot of times. Eventually it breaks.
Yeah.
And so I said, I really believe that. I said, you went way more hours, and they had assembled it, but I'm like, you went way more hours than what would be an assembly error. Like it's
Okay.
way more than one, right? You went 18 hours and it was shattered and whatever. And so I said, I don't, this is early on in that EFI era of that bike. So we hadn't seen these issues yet. Not enough people had really blown them up to know what's going on. And I said, what's the manual say for top end intervals? Because anytime a manual has an interval in there, there's some engineer who said, hey, we'd really like this to be the number, right?
Sure.
They know the math. Sure enough, the manual on that bike says 15 hours. And so that's for like your run of the mill, average Joe Blow, non-elite national kid, right? So sure enough, I think that guy had right at like 16 or 18 or whatever it was, and it just shattered. Now, if you change that interval to 12 on that bike, never have a problem. And it's the
Sure.
same with like a super mini for us, as an example, as to about high cycle fatigue and loading and whatever. Our super minis, what you do with a stroker, with a 112 on any brand bike, doesn't matter what it is the crank pin itself is moved. And so the piston in one revolution will go up higher and down further. That's what stroking means. So the
Okay.
piston has a longer stroke. So it's not bigger board in this scenario. It just moves a longer distance. So that gives you more engine displacement because we have a cylinder, right? And so it moves further. That's a bigger syringe or whatever we want to call it, right?
Mhm.
Well, guess what? A super mini turns the same RPMs that a 105 does or an 85 does, actually sometimes a little bit higher. And so that means that in the same amount of time at 12,000 RPM, the piston has to go a further distance. Well, that means it's traveling faster. That's the only way that's possible. Well,
Mhm.
a piston stops at the top and it stops at the bottom. So that means that I have to stop and accelerate that piston with higher levels of acceleration forces. Okay. So even though it's the same RPM, because it's moving faster in the same time, I have to stop it with more force. I got to pull on it harder, and then I got to push it harder to get it to go faster. That loads the part higher. So when we take a production 105 and it can go 20 hours on pistons, no problem. They generally never have a problem with that before you'll crack or break one. The 112 is a 10-hour, occasion. Basically, what we start seeing is like 10.2 hours, 11 hours, in that realm with a national kid, you start seeing skirt cracking. And that is just called high cycle fatigue. That skirt has been stressed and stressed and stressed and stressed, and it creates a little itty bitty micro crack, and that crack grows and grows and grows. And if you don't catch it in time, oof, it grenades. So we've actually pulled pistons out where a guy ran it a little over interval, and you start to see this crack formation. And so you're like, wow, thank God you got this apart, right? Because you were about to be disastrous. The only reason the 112 does that is because it's moving the piston faster and it's loading it or stressing it harder. Just like if I was in a top fuel car versus a pro stock car. The top fuel
Mm.
car is gonna, G you out a lot harder and it's harder on you. So that's where a forged piston would not crack, but then it's going to have rubbing wear that occurs more quickly. And then of course there's the power aspect. So you, me, and everybody else out there wants horsepower. Well, guess what?
Mhm.
Generally, now there's some exceptions to this, but generally, the way pistons are designed, cylinders are designed, the whole 9 yards, cast pistons generally make just a little bit better power. And I personally think it has to do with the heat transfer things and stuff we're talking about. Thermal stability, that the cast piston stays more round, the ringland stays flatter because it's not growing and moving so much under temperature. And because we're talking 10 thousandths of an inch of a difference, makes
Mhm.
a difference in power. So, those little details add up. So that's why a lot of times, like, hey, I could give you a forged piston, but you're going to give up a horse. Why don't we just change our piston at 10 hours? Like that's not a horsepower I'm willing to give up.
Two things that you've brought up in previous podcasts, and that was, and I never really thought about it. And again, I'm showing my ignorance as not being an engineer. You're talking about warming a bike up, how there might be three types of material, like you just articulated today: the piston, the cylinder, the rings, three types of materials. They heat up at different temperatures. Do you, like when somebody buys a motor from you, do you have a certain heat cycle, not just breaking the motor in, but like a proper warm up, like to make sure that everything seats properly?
Man, that's just another phenomenal question. So I actually have a sheet on this. I need to start shipping out with all our engines. I'd made it years ago, but so number one, why do we heat up our bikes? Right? Why do we do it? We've talked about it in the podcast, but basically
But for
you're
me, it
connecting.
was a boom.
Right.
I think this was so big. This was probably one of the most, of all the topics we've talked about, this was probably one, this, and this is the second half of my question, panic revving.
Right.
That's the two subjects that I've gotten the most DMs on. And that's why you're talking about this today is just hit that green light in my head again. So I don't mean to interrupt you, but I
Yep.
want the listeners that might be hearing this for the first time, the context of it. Go ahead with warming up the motorcycle
Right.
correctly.
So depending, like a two-stroke, four-stroke doesn't matter, but not every material in your engine is the exact same material. So for example, our connecting rod is generally a steel product. Our piston is an aluminum product. Our cylinder is aluminum, but has a plating on it, a Nickel plating. And then we have what we call thermal inertia, and I'll get into that in a second. We have water inside the engine, right? Our coolant system around the cylinder. So to give you an example is if I take my bike dead cold on a cold day, fired up, and I just put it on the dyno wide open immediately. Depending on the build, of course, if the tolerances are kind of where they should be, it'll seize. Why is it going to seize? The piston will literally stick itself inside of the cylinder. And so it's going to do this because even though the piston and the cylinder are aluminum, right, they should grow around a similar rate. The piston is pretty small in size and it's getting all the heat. It's like a flamethrower is on the top of that piston, right? That's where the heat is going, and it's super lightweight. So it's like taking an itty bitty thing, hitting it with a torch, and it heats up quick. The cylinder is much bigger, has more mass, and it has water in it. And that water's flowing through it, going to a radiator, hitting air, coming back around, right? So when it doesn't heat up as quickly and it's having heat pulled away. And so what happens there is that the piston expands, and you can, I mean, if you wanted to measure this out, I forget the number, but like if you put a piston in an oven and heat it up to 1200 degrees, which is not even close to peak combustion temperature, but let's say that's what was close, and then you measured it, it's going to grow like probably 5 thousandths. So that's a lot, right? Your piston to bore
Mhm.
clearance is only 1.5 thou or 1 thou, right? It's not that much. So if we were to do that, the piston would grow, the cylinder would not grow yet because it has all this mass that has to heat up and water. And then your radiator has mass and it has water and your engine cases have mass and everything's connected to each other. So the heat's going to want to distribute itself through all these parts. So that's why, number one, we have to warm up our bike. You have to. And like, realistically, like people miss this because bikes are so good this day. Like one of the reasons I think we run aluminum cylinders with a coating is so that they heat up faster. So we eliminate some of these problems, right? Like cars now run aluminum blocks, aluminum heads, like all these things because consumers no longer warm up their car. So the manufacturers had to figure out a way, right, to solve this problem. But on a four-stroke, we have an even more complex issue because sometimes the way the bearings work on those is not just like a two-stroke has literally a bearing, a ball or a needle or whatever. On a four-stroke, we have like oil film being the bearing. It's just like a piece of glass sliding on a table with water under it. We don't actually have a roller element. We have two parts that need a gap and then a film of oil to ride on. Well, guess what? If you have a steel crankshaft and a steel rod with the aluminum piston and they all have mass and whatnot, and we heat up everything else butt the rod quickly, it might tighten up on that wrist pin of the piston, or it might tighten up on that clearance with the the crankshaft.
Mhm.
So a proper warm up takes a long time because imagine if again I gave you a propane torch, just a small one that we all use around the shop or the house or whatever. Everybody has one, and I said, "Hey, stick that on your crankshaft until it's too hot to touch, the whole crank." It would take you 10 minutes, maybe 15, right? It takes a long time. And so once all of those parts get up to what we call homeostasis, where they're happy, all the parts are warm, they stay warm for a long time, right? And that you probably, if you've ever pulled a bike off a moto, the clutch, you got to change it out between motos, it's on fire, right? And it doesn't cool off forever, even after you pressure wash the thing, which is hard on your stuff, but it's on fire. So all that thermal mass is like, okay, I heated this all up. I got this big turkey I put in the oven. It's all hot. It's going to stay hot for a long time. And so that's kind of why you really got to prioritize a warm up. So I don't care if it's 2-stroke or 4-stroke, put in the time to get everything hot. That means when I touch my clutch cover, it's not cold. Yeah, my cylinder's warm, but I want the whole bike to be warm. When I touch that radiator, right? So the first thing that's going to heat up is going to be your cylinder radiator, right? Because it's circulating coolant and it's directly connected. But that needs to get hot. And then we need to allow it time to get our transmission, our clutch. So one of the tricks that you can do on a 2-stroke is it's a little harder on clutches, but if you're kind of in a rush to warm it up, you can, fire it up, warm it up to the point where everything's nice and hot to the touch. Like, okay, yeah, my radiator's finally warm to the touch. It's no longer like warm. It's kind of, ooh, that's warm.
Yeah.
Now you can put it in gear, put a little load on it, and kind of feather the clutch a little bit with some throttle, right? Just kind of give it a little bit of heat through the clutch plates, because every time the clutches are slipping, they build heat. Don't like smoke your clutch, right? Just kind of
Right.
feather it to the gear and get that transmission fluid to warm up. Get that transmission to warm up. Get the cases to warm up. And of course, your coolant will be all your cases are touching each other. They're going to warm up. So if you go to the Supercross races, you'll see the factory mechanics for about 10 to 15 minutes. They're going to fire the bike up, let it idle for a good period of time, and then they're going to go slowly. They're not whop, 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 not right away, right? They're just letting that thing warm up, and they're getting that whole engine up to temperature before that athlete even goes out to the starting gate. And then, of course, they get out to the starting gate, and they're waiting, and they're revving. It's continuing to warm up. But ideally, they get those things to the point where every single component in that engine is pretty much up to a temperature where everything has grown at the same rate, right? So our tolerances are not in conflict with one another.
So if we're watching this on TV, we're literally seeing the science of this right before our eyes. So they're warming the bike up in the underneath the awning and back in the pits. Then they're coming in, they're getting in this called pre-staging. They haven't rolled the bikes in yet. What does the heat cycle look like from the rig to not
Right.
rolling the bike into the gate? Because a question that I have, if you're okay if I pose it up now, and it may or may not tie in. Before we had grates, I don't remember seeing guys doing the slipping of the clutch because it would disrupt what you just packed the gate down.
Right.
I thought they were just warming the rear tire up. Are you telling me that it's a combination of warming the rear tire up and also getting that viscosity in the clutch plates?
Yeah,
moving?
100%. So
Wow.
starts being so important nowadays. I mean, they're everything, right? That
Yeah.
the elite factory guys are doing a whole bunch of things in a hurry with that. So number one, they're building enough heat into the oil and all that stuff to get the oil up to temp. Number two, imagine what your start feels like and looks like with the cold oil in your clutch versus hot oil in your clutch. The viscosity of oil decreases with temperature. And
Mm.
so the hookup of your clutch and the slipping and the way it feels will change based on how hot your oil temperature is. Number two, your clutch. So for example, when the clutch plates, they're made of material like everything else is made of material. As they heat up, they grow and expand, and that would technically change your engagement point on a lever clutch, on any clutch, but on like a hydraulic or a cable actuated clutch. So what they want to do is get everything kind of where it's supposed to be at, kind of at a good number, and then they're going to feather this clutch, put a little heat into it. They're warming everything up, but that's so that they can find a really precise point, right? So they're going to feather it, feel the engagement point, put a little heat. Everything's now up to temperature. And then from there, okay, cool. This is the break point. So I can now execute a start very precisely because everything's where it's supposed to be. But if you're sitting there on the line and your clutch hadn't heated up yet, and then you're kind of feathering it a little bit and it's starting to heat up and the oil's heating up as the gate's about to drop, all of a sudden that engagement point starts moving on you because these parts have not come up to their kind of homeostasis point. Once all of your parts are what we call fairly close to operating temperature, they kind of stay there. And there's a whole lot of thermodynamics behind that are way over my head. But I mean, basically, your oil is shedding temperature, your coolant shedding temperature, and there's a rate there. Like the hotter your parts get, the faster that rate of shedding becomes because the delta between the air and increases. So you get to a point where everything kind of just finds its happy point. So long as you're not, smoking a clutch, right? It's going to just sit there and kind of be happy. And then that's where you can get very consistent starts. Your clutch plates are at the right temperature, your oil's at the right temperature. But if you go out and practice, let's say starts, and you don't do all this stuff and you do it on cold oil, and then you do 1 in a row and 2 in a row and 3 in a row and 4 in a row, guess what? Completely different feel to your hand because your clutch is at totally different temperatures, right? So it's really hard to practice back to back to back to back starts with accuracy to what you're going to get on race day because your clutch pack is not the same. And that's another thing that the pros are doing. Like they're changing clutches every time they're on track for some of these teams. Why? It's not about the clutch. Like it's not about just it's too worn out. They're trying to optimize the consistency of their start. That's really what they're doing, right? And same with like Hunter had his mechanic had an interview. Hunter doesn't race or go on races on brand new clutches. So they'll ride a practice on it, take it out, inspect it, make sure it's right, measure it, whatever. But then that's his race clutch because he likes the feel of a one ride clutch, right? That's kind of something they're chasing. And of course, nobody's doing starts better than Honda right now. And clearly that's one of but all the teams are doing this, right? Let's just be clear on that.
Right. So now you've really piqued my interest, especially for the listeners, because I think when we look at the inconsistency of starts and the moto dads, they want to pull their hair out. They're like, we've spent hours, we've worked with a riding coach, 6 starts, 6 different results. This whole conversation fascinates me because for a human body, I've got all kinds of regulators. I can look at my heart rate. I can weigh myself before and after. I can figure out my perspiration rate. We have skin temperature devices that we literally look at core body temperature. What would you recommend for a listener? Let's say I have 6 motos today. How do I increase the consistency of what my rider is going to feel? And then how do I take that to practice to know, like you said, Hunter knows he wants a one ride clutch. How do we get the amateur parent to help their athlete understand that?
I think that's a really tough question because none of us are at that level. There are amateurs who will spend that kind of money, and have fresh clutches between every race. But for the most part, there's very few people that I work with that are doing that. It's not financially feasible for most people. And it's also, if you're not practicing that way, then it's not going to matter because then race day is different, right? So that's the area you have to be good at. But I think the worst thing you can do is go hot lap starts because by start 5, it's just not the same thing as start 1. Gotcha. And so maybe you take a bigger time between your starts. The other thing I see with starts, and it's this is like secrets that I have, but some people are good starters, some people are bad starters, right?
Exactly.
And no matter how much they practice, they don't seem to get better.
Mm-hmm.
And I think you can get better at starts. I actually know you can. We worked with kids and made them night and day better. But
yeah,
I think it takes the right approach. And I think that hot lapping starts is the very first reason why you can't get better at starts. Because your kid
elaborate on hot lap start. Just
you do a start, kid comes around, you put the whole shot device down, you line up, and you go do another one. And you come around, and what happens, in my opinion, and I see this all the time with like a lot of kids we work with, is that when they're doing that, usually their first start is dog shit.
Yeah. And
if it's dog shit, I'll do better. They come around and they do better. Okay, let's work on this. Let's work. And I always just amazed by this. How long, unless your kid's on 65s or whatever, like most of the kids that I get to deal with, they're beyond that. Your kid's already done like thousands of starts. Where I was saying about 4 starts, and I think so. Your kid has done 1,000 starts, right? At this point. And yet you still have to tell them every time, hey, you got to lock whatever your technique is. Okay, you're the type that's 2 feet down and you're supposed to lock in. And the second the gate drops, their feet go everywhere. They're behind them. It's like, you've worked on how many starts at this point and you can't even do this right? And then I see people make excuses for him. They're like, oh, well, yeah, they just screwed up. I'm like, no. Why are you practicing something and telling them to, and this is, I just hate this about some of the training guys. So you tell them that this is their technique and this is what they're supposed to do. Whatever technique you want, I think you can make any starting technique work. I really believe this because the execution is about your clutch and your throttle and shifting. It's not about where your legs are or not are, right? It's about how do we go? So the question is, whatever your technique is, and then you're just not going to not going to hold them to that. I just cannot believe this. And so like I say, go watch the Lawrence's YouTube channel. Go watch the elite starters over the years, the Alessis. They always are so consistent. They don't screw up. They don't get out of form. Whatever their technique is, they do every single time. And so like that blows my mind. So I don't think you should hot lap starts, because what happens is your kid sucks. He gets better the next one, and then you give him some reinforcement. Hey, your leg got loose. Oh yeah. And then they hold their leg tight. And then, and they're getting a feel for that engagement, that dirt after the start, that today, how the bike's launching, right? Like it's your power, let's say in a 30-degree day versus a 100-degree day, your bike's making 5 horsepower different.
Yep.
Right? People don't think about that, but it is. So at the end of the day, like the kid figures it out. And by start 12, you're like, damn, that was a good start. Let's bring that to the race. But then the problem is you go the next day, 1 day later, and his first start is dog shit.
Yep.
And you're like, dude, we just worked on this yesterday. Oh, well, I'll get better. I'll work on it. Well, guess what? On race day, how many starts do you get? You get one opportunity. You don't get to get better at it. And so I think that that's where people go wrong. So I think it's a combination of like, okay, at the ultra elite level, if I wanted to whole shot at a supercross level, I have to do the things we talked about. But if I want to be in the top 5 at an amateur national, you just have to be consistent, a good starter. You got to do the things right, but I don't think you need this crazy level of clutch, but you should be warming your bike up. You should be feathering that clutch, getting the clutch warm, right? Doing the little things that these supercross guys are doing. And if you have a dirt start, you need to do it behind the start, right? Kind of get the start.
Exactly.
And that gives the kid the opportunity to feel, where is this exact engagement point? And then the other thing I see, and I do not understand this, actually, I don't follow their channel that much, but she does such a good job on content. I see it all the time, is keeping up with the Wises, who one of the moto moms has this huge social media account, and she's just behind the scenes of like riding. So I see clips and this and that. And she was at Freestone this week. I saw it on my feed, and it was like, my kid used to be a good starter, and now he's no good, or whatever it was, whatever she had said. She's probably way more nice than I said. But the very first start she showed, and I see a lot of kids do this, I don't even know they do it, is they're on the front brake and the clutch is out so much that rear tire's spinning in the dirt. And I'm like, that's not right. I'm sorry. And it's hard on your bike. You know what I mean? Like, it's really hard on the clutch, and it's building a ton of heat. And guess what? As you build heat in that clutch, it wants to engage harder. So if you don't move your hand, the clutch is swelling and expanding, and it's going towards your pressure plate. So without moving your hand, it's wanting to go worse. And that's another area.
Explain that again. So once the plate's engaged?
Yeah. So let's say, okay, so the way your clutch works, there's 2 discs.
Yeah.
So there's a whole bunch of them, right? And when you pull in your clutch lever, it separates your discs. And when you let off your clutch lever, a spring pushes them together. And when they push together, friction is what makes you go. Okay.
Yeah.
Well, so the 2 concepts are no engagement, bike won't go. Bike will go, right? What happens if this plate and this plate got bigger in this scenario where they're compressed with a spring?
They're going to stick.
They're going to get tighter, right? Because the spring's not moving.
Right.
So what happens on a start is like fully in on the lever, and then on
let it out a little bit.
So fully in would be like this, like a knot, right? And then I'm in my engagement point. So now I have a little bit of daylight, but they're rubbing. But as they're rubbing, they get hot. Okay. So as they're rubbing, they grow, which is the same as them tightening up. And if your hand doesn't move, now they engage harder and harder and harder and harder and harder. And then like they're going on their own. Your bike is going without you wanting to go.
See, I think that sheds a lot of light on the moto parents, are like, what the hell's going on? Because they watch the video and their finger is sitting still, but the wheel is, that's why I wanted you to elaborate on that, because I've heard that question before. I watched the film. He didn't let the clutch out, but the rear wheel started going, and then they think they've got a clutch problem. You don't have a clutch problem. You have a physics issue going on.
Right. How you decided your feather point to engage. So like what really needed to happen was, and you can have a clutch problem. Like if you shot a hydraulic clutch, by the way, pro tip for all you moto dads, and me and Andrew Short, he's the one who clued me on some stuff I never knew about this. Okay. So like he was here at the shop the other day. We did shout out to his kid. Hopefully he's healing up really well. He had a big one recently, but,
oh, did he?
Oh, really bad. I don't know all the details, but like broke his back. So he's walking around. He's okay, but yeah. So all the KTM's, Husky gas hydraulic clutch, we have noticed that clients will come in with a 40-hour bike. And like, if you decide to bleed the clutch, it's just filthy. I mean, it's like, how the hell is this sealed system look like motor oil? Like it's
Mm.
terrible. And you're like, is it somehow between the engine? It's not.
Right.
But what happens is that fluid gets really old. It gets a bunch of particulate in it. It gets dirty. And then there's little itty bitty holes that make all this work and those little seals inside of your masters, And so basically, we've seen guys who will have like their clutch on the line and all of a sudden this goes limp and the bike goes. So this doesn't work anymore. You lose the ability to pull in the clutch on the hydraulic. And it's like getting air in your system or whatever, similar to that. And then you can't pull in your clutch. And then usually you pump it up and it comes back and you can ride your moto, but on the starting gate, it costs you a start, right? So you should be 100% on those bikes. Anything past, I would say 10 hours, but anything past 20 hours, if you own a KTM or Husky or gas, you need to be servicing that clutch system top to bottom as far as bleeding it, cleaning it. It has to be perfect. And anytime, if you drain it anywhere in there and there's dirty in that fluid, you have to do a full service because it's really hard to get it out of all of the areas.
Sure.
And there's a very specific process that Andrew was telling me that he's going through. And I'm not going to share it 100% here because I don't really fully understand it yet. But they're trying their absolute best to prevent basically particulate getting anywhere within that system. And it does. So that's, if you see any amount of like non-perfectly clean fluid in your clutch system, which I promise you have 20 hours, it's going to be dirty.
Yeah.
And you need to really service it because all that particulate can cause you one of those starting failures. And I mean, it's probably the least service part that I see from parents. Like they're like, oh, I haven't serviced that in 40 hours. And then I'm like, well, and then you wonder why the clutch went away on the start line. This item is as important as your engine oil, every bit. And they change that all the time.
See, and this is the type of feedback I get from the listeners. It's these little nuggets that, if you listen every month, it adds up over and over again. I want to go back to, would you recommend, I've got a racer, I've got 6 motos today. Do I put a fan on the motor when I come in to try to bring the temperature down? I apologize, I'm being very ignorant here. Do you have temperature gauges on the different materials to see what that internal temperature is? Like, how do you know that you've got good homeostasis, as you called it, amongst all the different material types in between motos without crossing the threshold that it's so overheated that if you heat it up more, you're making it worse than making it better?
I think one of the reasons the factory guys service the clutches every time the bike's on track is it's a great indicator of total heat load. Because
Okay.
if you got bluing of the plates, that means that you got those things up pretty hot. And then the clutch is what contributes all the heat to the engine excessively. So if I put your engine on the dyno, don't touch the clutch, hold it wide open at peak power, and I have the proper fans on it, right? And it's not even that much fan. You'd be shocked at what it takes to cool these things. It could literally do that until I ran out of gas, and then I could fill it up. It could do it for 24 hours straight, no problem, all day long, without hesitation. It would never overheat. The parts would stay within realm. Absolutely perfectly fine.
Wow.
Where you start overheating your engines is the clutch. The clutch is a device that takes horsepower and turns it into heat. That's what it does. That's the physics of your clutch. So when you slip the clutch, anytime you slip it, it's taking any power you have generated and it 100% converts it into heat. That heat has nowhere to go except your engine oil, which then, of course, contacts all of your engine parts, distributes it heat, goes into the coolant system, goes out your radiators. Now, we have a level of that we're accounted for. The bike can cool quite a bit of clutch abuse. However, I mean, we see it routinely. There's guys who over-abuse clutches. And when they over-abuse clutches, then that's when you really start cooking that motorcycle. And then it's very obvious, right? Like you get to see bluing on your clutch plates and other parts start to look a little hot. If that oil is really just cooked and smells burnt. All of those are signs that, hey, I got this thing really hot. Now we have on the four strokes data that can tell us, hey, how hot did the coolant temperature get? But kind of a little hack on that is it can only get so hot because then it boils, right? So like you're only ever going to see a certain peak and then you're going to know, well, it's going out the dang radiator thing. So the bike's hot, right? But that's as hot as the water is going to get. It's not going to get any hotter than that. So that's an area where it doesn't tell the whole tale. But if you're puking coolant, you definitely are hot, right? There's no question about that. And then number 2, really look at your clutch. I think that's why the teams do it. They're looking at that for any signs of potential engine distress. I mean, I've been at some races. I have some friends at some various teams, and at Daytona 3 years ago, Barsha changed an engine on a 450. And basically it was between practices or whatever. And I was talking to the guy, my buddy over there, and I'm like, hey, what you changed an engine? Like, what the heck? He's like, yeah, we pulled clutches, drained oil, and we saw something look a little off. We don't even want to risk it. He didn't notice anything. Bike was running fine. At that level, if they see a clutch got hot, they're like, we're not going to risk any part in that engine. Just put a motor in it. We have motors, right? At our amateur level, we can't really do that for most people. So just keep an eye on things, right? And it's like at an amateur national like Loretta's or coming up Spring Ding or Freestone, those are shorter races. But if your clutch got cooked, your oil got cooked, you should definitely be changing that. Right? Put
Mhm.
fresh oil in it. What's that cost you for your week? It costs you nothing. I mean,
Mhm.
ultimately it's nothing. So those are the things that I would say there. But it's really hard to really know. And then what we do like on teardowns of engines, like pistons, when we look at a piston, we can tell kind of jetting and overall heat load on a two-stroke. And that is the underside of the crown. So flip your piston upside down, depending on your premix. Like this is like kind of a black art, right? But if you flipped
Yep.
it upside down, we can tell how hot in general that crown got. And that tells us a lot about your jetting, how hot you're getting it, things like that. And I mean, it's a great, great tell. I mean, so like, we'll get pistons in that have, customers are very successful with our stuff and like, oh, wow, this just looks so good. You're on the money. This is great. And then you might get a guy who's like, oh man, we're doing great. And then I blew this up. And you go look at this piston. You're like, dude, that thing was cooked. It looked like somebody put that on a blowtorch and, just fried that. I mean, it literally looks like it came out of a freaking broil setting on your oven, just smoking and cooking. And then you gotta, you gotta evaluate where and why that comes from, which is more challenging. But okay, did we have a fuel delivery issue? Did the fuel hose thing not work correctly? Did you run out of gas? Is the jetting wrong? Or smoke the clutch? It was a mud. And hey, was it a mud? Oh yeah, it was so muddy. Radiators were packed, and a lot of bikes blew up. Oh, okay. The bike wasn't able to shed the heat that it was generating because the radiators are not getting airflow and they're completely caked with mud and they're not able to transfer heat. Well, I'm sorry, but this is dirt bikes, and eventually you're going to abuse equipment through a certain condition that's just beyond the realm of physics. There's just no way around it. And that's unfortunate, right? Then you never want to see a client have to go through that.
You just brought up something I never thought about. Let's say that one year at Daytona when Chad Reed got his bike stuck in there. When you see those kinds of conditions, this may sound like a very ignorant question, but again, I'm not an engineer like you are. Would you say to somebody, hey, we're going to put a brand new clutch in this and stay off of it as much as possible? Or do you, like with Hunter, wanting to have that feel for that clutch? Is it safe to assume that the conditions are so crappy that it really, his feel for the clutch is more, let's just do everything we can to get the bike to go the distance? Like Chad's bike literally with 1 lap to go or 2 laps to go just stopped in the middle of the track.
Right.
It wasn't that he wasn't trying to survive, keep the bike alive. It just eventually gives up the ghost. Or are you better off having something that's a little bit more worn and torn? Where, from an engineering standpoint, where is a kind of freshly broken in better than brand new? Or in that case, a brand new, just buy it a little bit more life?
That's an amazing question. Let's say you're at Loretta's and it's just the muddiest of mud, not like a raceable mud, like hey, the track's pretty decent. It's gonna be a little, we're talking like it's a mud moto. It's sloppy, it's muddy. If you stay up, don't crash and survive your top 10, like
Yep,
that kind of
yep,
deal.
exactly. A practice
Um,
race.
yeah, I would run the crappiest equipment I got. Like, there's no
Yeah, me
question. Why
too.
would I go tear up my nice bike?
I
So
don't think
that's
people realize how a lot of the factory teams will bring a practice bike if it's going to be a total shit show.
Well, I mean, so like the year that Dax won, it was a mud year, terrible year. I know some guys at the team that year, and like they've moved on, but like, yeah, they put in total garbage equipment for the terrible motos, right? Star was like, we're not going to go put in a nice race motor for that. Like, what the heck? You're not going to use the horsepower.
I tell my
So
parents all the time, please, I know it's financially difficult, but try to keep at least one bike. It could be 5 years old. Just practice in the mud because you're going to go to Loretta's tied 2-1 on Saturday. It's going to be a mud fest. You're going to be devastated that you lost because you're not good in the mud. And I ask you, when do you practice in the mud? And you say, we don't. And I'm like, well,
there's
there's that. There it is. It's gone. That
Ricky
opportunity's
lapped the
gone.
field at Millville. And he said that he got so good at it because when he went to the MX Nations and got lapped by like efforts in the mud, he's like, all right,
Never again.
I'm going to go ride in the mud now. And then he figured it out, which there is a skill to it.
Mhm.
And then, okay, now he literally lapped second place. Like,
Well, would
guy
you
was
rather be
unbelievable.
Kevin Windham that gets excited when it gets muddy, or would you rather be the guy that's just bemoaning the
Hey,
fact
again,
that the right skies have opened up and you know you
yep.
suck at it and you're going to go
And
back?
attitude is everything, right?
Yeah.
So I
I didn't
agree.
mean
So
to
yeah,
interrupt you, but
no,
I
no.
just I'm always amazed. So I interrupted you in regards to, do you think it'd be better to have a fresh clutch with more life or one that you have a little bit of time on it?
So the way I would go about this is you measure your pack size. So you actually can measure them individually, make sure your plates are within spec. And there's a spec that
Hmm.
you as a parent can kind of come to terms on. There's a spec in the book. Like, get a new one. Okay, that's a new one. There's going to be a variance on them, right? And then
Sure.
from there, this is kind of like beyond worn on our practice equipment. This thing's finally gave up the ghost. Measure it out. Now you know the range. And I would say, as long as my clutch is in this realm and it didn't get hot, I mean, I didn't blue it previously. I didn't have all my plates blue or they're brown or whatever. Okay, that's good. I'll put that in the mud moto. I'm fine with that. Now, hey, son, get off the clutch in the mud. Number one, why do you need it? The tire spins.
Mm-hmm.
Let the tire spin. We don't need to worry about the clutch, right? Let
Yeah.
the tire spin, number one. And number two, unfortunately, kids nowadays, a lot of them are taught, you do this and then you use the clutch. Hey, that's harder on the bike because you don't need all this power. That means you're pulling the power away. So why don't you just roll on the gas? And then we only, because power is heat. I don't care what engine builder wants to tell you otherwise. That's the thermodynamics of it. The more horsepower you make, the more heat energy we have produced, period. That's how
Mm.
horsepower works. So, that is how it works. So at the end of the day, if you're wide open all the time, you're building a ton of heat and then you're on the clutch, slipping it, extra heat, bike doesn't want to hold together. And I'll give you a good example of this. This blew my mind. I think the kid's great, so I'm not talking shit on him. But Max Voland comes from the factory amateur program at KTM, goes to the Baker's factory, right? Like coming up the ranks. He moves over to PC. If you remember, like, I think the second, well, all the 250 West Coast races that year were like a mudder. But I think it was the second round. It was really muddy, if I remember right. And it might have been the first, second, third, whatever it was. He like got a great start. He's out front. He's ripping. I mean, he was the fastest guy on track, if I remember right. And then the bike made it like 3 laps in the main event and he smoked clutch. And it just like, how do you smoke a factory level motorcycle's clutch, which is as good as you can possibly make a clutch?
Right.
3 laps. And the answer is because if you watched him ride, he was wide open, hammering the clutch the whole way around the track. And yes, that's a technique. That's how you ride. It's not the right way to ride, in my opinion. But at the end of the day, the proof was in the pudding that he couldn't even finish 3 laps. And I think that I'm sure he's better now at that. He's thought about it, reflected on it. They've worked on it. Okay, hey, if those conditions, I need to be easier on the throttle and easier on the clutch and my bike will make it to the finish line, right? But as a parent, you should be teaching this at 65s.
Well, it's not about whether you agree with me or not. It's the law of physics that will eventually win. It's like we talk about all the time. If I drop my pen, I can tell you that gravity doesn't exist, but you just saw evidence of it. Yeah, I can argue with you, but evidence, gravity's going to win. Yeah, that might be your writing style, but I'm telling you from an engineering standpoint, you will grenade it. And then you choose to go the opposite direction. Then you go, well, why did it grenade? Well, it's the law of physics. It's engineering. It's heat. That's why I really appreciate you giving all the detail on this, because it goes beyond just, hey, did you warm your bike up? Do you understand why warming it up? 3 types of material. That's a huge aha moment. The idea when the clutches start to heat, they press together because of heat and expansion. Yeah, you want to get the chain tight, but now your wheel's starting to slip. Like you said, not coming in and just resetting your start device and just blowing through. Yeah, that's what I'm, like you say, you're not being judgmental. You're not being critical. It's just, don't don't argue with the law of physics, because you will lose. It's not an if, it's a guarantee. It's silly to
And,
me, but
and I think what we're struggling with, I was thinking about this one day. I think you and I talked about it, but clutches are becoming more of an issue. Like I have more clients now than ever who tear them up. And I'm like, man, why is that? The bikes are better than ever. Like there's no question on that. And I think it's 2 things: poor technique, plain and simple, period, end of discussion. People are hammering the clutch and there's just more coaching to do that. And I think that that's bad. But secondly, the reality is the bikes are getting better. They are making more horsepower than they ever did before. And so because of it, and it's slow, right? They just inch forward over the course of the last 20 years. But I mean, I started racing big bikes right when the YZ250F came out. So that's right around my, I think it was out 2 or 3 years before I got onto it, or when I was moving up to big bikes. But that bike on my dyno, I think is a 32. I mean, I'd have to go get an 01 or whatever, but I think it's a 32 to 33 horsepower bike. Now we have 250Fs making bone stock, like KTMs will make 45.
oh, 13 horsepower. Jeez.
Yeah. So that's the evolution over this little bit of time. Now the Yamaha doesn't make that, but it's not, it's about 40 for me. But like long story short, the Yamaha's way up too. Well, did you know what? This is kind of funny. You can take the clutch plate out of that 01 and it drops in the current Yamaha. They haven't really improved that clutch design at all.
With a 12 horsepower improvement.
Right. So the clutch is capable of holding the load. They have done that engineering. Okay, it can take it can clamp together and it won't slip. But what has not improved, and this is thermodynamics, it's very hard to improve this, is when you slip it, now we're slipping away potentially, let's say 10 to 12 more horsepower. Or if you got a race bike, you're slipping away 15, 16, 17 more horsepower than you were back when that clutch was designed. And the reality is, if you kind of study the Yamahas, guess where that clutch came from in that 250S? Oh, by the way, it fits the 125. Well, the
Mhm.
125 was around the same horsepower, but a way smaller curve. So when you were slipping the clutch on that bike, you were generally slipping away a lot less horsepower. So we have not come up with a way on these new bikes to mitigate. If you want to slip the heck out of that clutch, we're going to build way more heat than we ever built before. Guess what? We still have 2 radiators and 1 water pump. It's all the same stuff. Like, radiators haven't changed at all. And so we kind of have a limit as to how much heat we can throw away, how much we can reject. And I mean, you could tell Yamaha could say, look, we're going to triple the size of those radiators, but we just don't know where to put them. Right? Like, we just don't have a place for it. And so that's
Yeah.
kind of something you have to keep in mind. And to me, the engineers at Yamaha, myself as an engine developer, think, well, you have more horsepower, so use the clutch less. That's my thought process.
Sure.
But the riders ride how the riders ride, right? And so that's
Mhm.
kind of the other way. It's like, well, I'm going to just pin it and then just slip the clutch and fan the clutch. And this is another area I don't understand. I see it all the time where, like, a lot of 250F guys are up on the limiter all the time and out of the corner. And if they're not quite there, they're feathering the clutch, and they're
Yeah.
really close. I mean, they're constantly above 12,000 RPM, and we have data on that, right? Dude, your bike will lug all the way to 9 with 0 clutch. So why are you clutching?
Mhm.
It's an area that I have not quite understood. And it's like, oh, it feels faster. Yeah. Every time you pull it in, it spins up the RPM, it spins up the weight in the crank and the flywheel and everything. And then you let it out and it's like, and it
Mhm.
hits you with a hammer. But that doesn't mean it actually drove you down the track faster. You felt that instant little, like, jerk. You can feel that in your hands. But are we actually making lap time? The answer is no. And I don't know. I don't know why that's become so prevalent. I think it's a bad habit. And I think that, well, Caden doesn't ride that way. And he won 2 championships back to back and Horizon Award winner. So you can do it without it. You can ask Kenny. You can ask, like, Chase.
Yeah.
Of course, people hating on him, but you can ask the Lawrences. You can ask a whole host of guys who don't ride that way. Then on the flip side, we've got the Tomacs who do. Now he doesn't clutch bomb. He kind of slips. But
Right.
and I would say, I don't know for sure, but I watched his technique this year. That's probably the least amount of slipping I think I've ever watched from him this year. I think they've really got his power in a place where he's able to just get what he wants out of the bike. I
Right.
think that's why he's the best. I don't know about you. Is this the best year we've ever seen from him?
Yeah, it's pretty hard to argue with that. He looks so good and comfortable. And I'm glad to hear you say that because, like, when I teach performance camps at a level, I have 3 levels that I teach, 1, 2, 3. Level 1, I always say, "See how much light's in between my hands? None. This is your gas, this is your brake. No time in between. You're either on the gas or you're on the brake." And at the level 1, people like to argue. They're like, "Yeah, but what about my roll speed in the corners?" A bike that has no input's gonna always stand up. So you keep getting pissed off that you're high siding in a corner. It's when the bike doesn't have any input. When the bike has no input, it stands up. So you're coming in trying to get a lean angle. You're pulling the clutch in, to your point, right? Revs are up. You've got so now you've disengaged the clutch. You've lost your forward momentum. Now you go right in a left-hand turn. It's so fundamental, but yet it gets overlooked because people are doing the da 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 da.
Well, and that's a great point. You just brought up, I mean, a phenomenal point. Do you remember Kyle Swanson? I had him on the early
Oh
part of
yeah,
this channel,
yeah, yeah.
and he
Mhm.
had some, like, social media thing he said years ago. It was the best thing I'd ever heard on this. I love Kyle for this. He said, if you were riding a mountain bike on that out there on the track, would you come into the corner pedaling full blast, slamming on the brakes, letting on the pedal, slamming on the brake 6 times through the rut?
Yep.
Absolutely not. You would try to
That's right.
carry as much entry speed as you could, flow through that turn as best you could. You would try never to touch the brake, right? You would
Mhm.
brake and then be done in one smooth corner because on that, you have no excess of power. You have no extra, it's maximizing. And I think that your example of, okay, how do you set up a suspension? So guys like, oh, I can't turn the bike. Okay, cool. What do we need? Oh, I need more front grip. Okay, cool. Let's work on that. And then they get in the corner and they're hammering on the brake, and then they get off the brake and they hold it wide open. And then, like you said, they 5 times with the clutch, and the bike goes from front to back to front to back to front. It's like the bike's never settled. So how are you supposed to ride something that's not either on the front or on the back or fairly
Mhm.
neutral? However you set it up, you're
Yep.
going to upset the bike every time you do that. Now there's techniques, like you come in, you
Sure.
kind of overcommit, lean over a little too hard,
Mhm.
flick the clutch, and it pops you up to
Yep.
get you from falling. Sure, that's fine, but it should be once. And
But
that's
think
something
about
that is tough.
why would you low slide? Either you've hit the inside carcass or you're not going fast enough. So
Not
that's
fast.
the only way you'll ever low slide.
Yep.
So when you find yourself falling low side, simply go in faster, which is counterintuitive. Then on the flip side of that, why are you high siding? And then you can see this literally manifest itself. Look at an amateur corner. You have a G out at the entrance, a G out at the apex, and you have a G out on the exit. Why? Da, 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 da. Stand in that corner at Loretta's and watch. Da, da, da. You can watch the wheels accelerate, and you can watch the
Yep.
corner build with the 3 G outs. Then you go to a pro national.
Nice.
It's just
It's so
one
nice and
roll through.
refreshing to ride pro tracks, right? Because they make so much better lines.
And this is why the amateurs don't understand why the pros hate when it's an open ride day, because you get a completely different track for these types of reasons. So
Speaking on that note, it's like if you go to training facilities, how do I put this? So I think it's frustrating. This is another example of frustration at amateur races, local, Loretta's. Every kid goes out there and tries to set the world on fire in practice and creates the worst hooks and the worst ruts. And it's just terrible. And it's like, number one, it's practice. Number two, like, make a nice line for the next guy. You know, that way the next lap you come around, you can actually rail a rut, not have to, you know, like have 6 corners within one. But it's just not how we are, right? It is what it is.
no.
But yeah, you go to the
That's
pro
something-
races and it's like beautiful.
Well, I teach that at the level 1 is go where everybody else doesn't go, plain and simple. Because where everybody's going is essentially the main line, not always the fastest, but it's the main line. Well, most moto heads can pretty much dial that main line. That's not where you're learning. I always say when I go to a performance camp and we have a perfectly groomed track, I ask them to please go out and create 3 lines. Come in and super slow, just drag the front wheel and create an inside rut. Do that for 4 or 5 laps. A couple of you guys go create a middle line. A couple of you create an outer line. Shape it up to how you want it to be. And then what we always say is we'll work a particular section, work it for an hour. We'll on and off, of course, come back out. And before we ride it, I have everybody sit and look at the berm. You created what you're looking at. Do you like it? If you don't like it, let's change it.
Yep.
And then we make some few adjustments and then we go ride and come back. Oh, check it out. We don't have 3 G outs. Well, how is that? Because you're not doing the clutch. Well, let's look at your lap times. Miraculously, you're faster.
And what's amazing
why-
too, like staying off the rear brake. Once you're off it, stay off it.
Stay off
Right.
of it.
And that's something that is even the front, you know, like I see some training facilities teach a lot of what I call advanced techniques. Advanced techniques are, I might have to what we call trail brake or whatever. Your front brake all the way through the rut, or if you make a mistake and you kind of start to ride the tire up the rut, sometimes you can just kind of just sort of tap the front brake to kind of, right? But a lot of the kids take that to every turn. It's like, no. That's a hack for when you screw up. When we're training and practicing, our goal is to not need that. Our goal is to execute corners without these cheats and to have that tool in the toolbox for when you do screw up. But a lot of people
Think
don't
about
grasp
this.
that.
How many people don't know push left to get the bike to lean over to go left?
Yeah.
That's what astounds me. And I teach that at my level 2 class. You guys are you're forcing the bike trying to get a lean angle, realizing that you don't turn the bars.
Nope.
And it goes back to street bike and stuff. But
Yeah.
well, brother, we're going to keep this conversation going again because I want you to get into, like you're talking about, whether we get into a little bit deeper into the motor itself with rods and bearings and stuff. Because when we talk about the word strength, right? We talk about, I love what you've really brought across here today. Every time you grab that clutch, you're just heating up a motor. And eventually that heat's got to go somewhere, which eventually ends up in the radiator. Now we're in a power struggle for overall heat management. And we all know what heat does to a motor, robs it of power. Of course, we are spoiled. Remember when the old KX500, Mako 490 Spiders, they didn't even crank those bad boys up on the starting line until it was just about ready to go because they knew in 3 laps, they lose 50% of the power.
Yep.
You know?
Yep.
But
the old air-cooled days, way different.
Oh, totally different world. But isn't it interesting how you didn't argue with the law of physics because you knew once that thing got hot, you were losing power. Even though it's a 500cc and it was a monster, you still realize you're on borrowed time. So,
Yep.
Well, brother, I want to thank you. We'll continue this conversation, trying to find power in a motor, trying to find what strength means in a motor, and we'll tie it back in with the body here as well. On behalf of myself, Derek, thank you so much, guys, for all the subscriptions. Thank you for following, the likes. We'd like to thank Precision Transport once again for all their support, and we will catch up with you guys next week. Thanks so much, Derek.
Thanks, Coach.